What is the frequency of Bobby's wave? Okay, so in the question it says he makes 6 complete waves in 12 seconds. So therefore 6 waves in 12 seconds, 12s. So that means one wave takes 2 seconds. Now that's just a period. We know the equation for frequency. So frequency is equal to 1 divided by t. That's the symbol for period. T is the symbol for period. So F is equal to 1 divided by 2, and so that's 0.5 hertz. That is the frequency of Bobby's wave. What is the wavelength of Bobby's wave? Okay, so we know that the ball is 10 meters from the edge of the pond, and he counts exactly 4 complete waves. So 4 waves, let's write this. This is part 2. This is part 1. So part 2, 10 meters is equal to 4 waves. So that means 2.5 meters is equal to 1 wave. So therefore the wavelength is equal to 2.5 meters. Alright, so the next part of the question, calculate the speed of the wave, show your working. Alright, so we know that the equation, what's the equation for speed? The speed is equal to f lambda. So f, and what's lambda? I'm just going to put wavelength. Now we worked out the frequency was 0.5 hertz. And the wavelength was 2.5. Remember, it was 10 divided by 4. So if we times by 2.5 meters. Now remember, hertz, the units hertz is how many waves per second. So if we times the 2 units together, we get meters per second. So 0.5 times 2.5 is 1.25 meters per second. Explain your answer. Is Bobby right? Because Bobby thinks that his ball will be carried by the waves to the shore. Alright, so okay, so explain your answer. Now, if we assume that this is a transverse wave, it's only going to move up and down only. So move up and down because it is a transverse wave. So up and down only because it's a transverse wave. Energy is transferred to the right. So it's only moving up and down. Energy is transferred to the right. For this question, the table shows typical wavelengths of different parts of the electromagnetic spectrum. So in the table, on the left-hand side, you've got the name of the region, and on the right-hand side, you've got the typical wavelength in meters. So A, very short wavelength radiation can be hazardous. Which 2 of the following statements put together then can explain this? So they have to be put together, and there are 2 statements. Alright, so let's look at the first one. Very short wavelength radiation has very high frequency. Now that's very true, because if you think about gamma rays, it has a short wavelength. Now the shorter the wavelength, the more waves you can fit in per second. So that means that has a high frequency. If you compare it with radio wave or microwave, because the wavelength is long, the frequency is a lot lower, much lower. So yes, so the first one is true. Very short wavelength radiation has very high frequency, yes. Okay, so radiation of wavelength greater than 1 centimeter can cause cancer. So 1 centimeter is 0.01 meters. So because it's greater, it's going to be in the microwave region or in the radio waves region. And that's very unlikely. So it is unlikely that radio waves can cause cancer. Microwaves don't cause cancer. I mean, they can cause heating effects, but it is less likely than gamma rays, let's just say. So X-rays, gamma rays, and ultraviolet, they are more likely to cause damage to cells. Why? Okay, if you look at the next one, the energy of a photon is directly proportional to its frequency. Now, the answer is this one. This is quantum mechanics, so I'm going to write down the formula. E equals hf. Now, E is the energy of the photon, Now, photon just means individual packets of energy. So if you think of it as a particle of light. So the photon is a particle of light, and that is directly proportional to the frequency. So the higher the frequency, the more energetic that photon is. So H is Planck's constant, and that's 6.6 times 10 to the minus 34. Okay, so H is Planck's constant, and F is the frequency. So if you think about it, the higher the frequency of the wave, the more energetic that wave is. So for example, gamma rays, X-rays, ultraviolet, they have high frequency, so they have a greater energy for each of those photons. So it's that one. Now let's look at the other ones. Long wavelength radiation is not absorbed by living organisms. Now, long wavelength radiation can be absorbed by living organisms. So for example, radio waves, microwaves, they can get absorbed by cells, but that doesn't answer the question. It doesn't explain what the question is asking. So because it's not absorbed, that doesn't explain why it can be hazardous. And the last one, very short wavelength radiation is absorbed by the atmosphere. Now, very short wavelength radiation can just go straight through the atmosphere. It is more likely, in fact, radio waves can get absorbed by the atmosphere. I mean, very short wavelength is absorbed. I mean, it will just go straight through. I mean, depending if it hits the atoms or molecules, then very short wavelength radiation can be absorbed by those particles. But that does not explain why very short wavelength radiation can be hazardous. So that's irrelevant. So the correct answer is 1 and 3. So it is very short wavelength radiation has high frequency, and the energy of a photon is directly proportional to its frequency. Let's have a look at part B. So explain the process by which very short wavelength radiation damages living cells. Use appropriate scientific terms in your answer. So I've written down equals HF. So the higher the frequency, that would imply that it has a short wavelength, the more energetic it has. So what happens if it knocks off an electron? So what happens if it knocks off the electrons? So it will be ionizing, won't it? It will be ionizing. So for the first mark, you would say it is ionizing radiation. Also, it can cause mutations. Okay, so because it's ionizing, the electrons are knocked off. Electrons are knocked off. So that means that the chemical reactions take place. So chemical reactions take place, or different, rather, we can say that different chemical reactions take place than normally. So, and that can cause mutations, and that can damage DNA. All right, so the radiation, because it has a high frequency, it is very energetic. And what happens when it hits an electron? The electron will be ionized. Sorry, the atom will be ionized, meaning that the electrons will be knocked off. So the atom will be ionized because the radiation is ionizing, meaning it has a high energy. The electrons are knocked off, and so therefore the chemical reactions will take place, and these will be different chemical reactions than normal. So therefore they can cause mutations because they change the chemical reaction, the normal chemical reaction, and it can damage DNA.